Hello, AP Statistics. So let's say you find yourself in possession of a lot of categorical data and you would like to make a display so that you can get an idea of what it looks like. So categorical data, remember, is when you answer your question that you've asked, your variable has an answer that's either like a label or some sort of word usually. So it's anything that's not numerical. Numerical is counts or measurements. So usually we're talking about like, hey, what's your favorite color? Or it can even be a number that doesn't count anything or measure anything. Like, what's your zip code? That doesn't mean anything. Categorical data shouldn't make sense to take an average. I can't say, well, I live at 90210 and you live at 12345 and that averages out to the Midwest. Okay, so it doesn't really work that way. You can't average your jersey numbers and your student ID numbers and things like that. You can't average vanilla and strawberry and get butter pecan. So we're looking for data that has to be looked at a different way than and most of the time we're going to deal with categories. So when you talk about categorical data and you're going to talk about it, you're going to write about it, most of the time what you're going to look for is the most frequent, the least frequent, and anything else that you might find interesting. And don't be afraid to say, what is going on here? What is this graph saying? So when you go to make a categorical data graph or to read one, you're usually going to see like a bar graph or a pie chart. Those are very common. In a bar chart, you may have frequency. Frequency is literally how many there are. So it looks like there were about 150 freshmen here. Or you might see relative frequency. The relative frequency is the proportion of values. So for example, it is the frequency divided by the number of observations. So if you know that there were 20 strawberries out of 30 different ice cream flavors, then the proportion would be 0.667, okay, or 0.6 repeating. That would be my relative frequency. You could write it as a decimal or you can write it as a percentage depending on how you want to address the problem. Now, a pie chart is always going to show the categories as a total out of 100%. So if I am looking at this data and I want to talk about it, if I'm going to write about it, write a few sentences about what you see, you always want to make sure you mention context. And remember that context means that you're going to use the name of the variable in what you say. You're going to put units on it if it has units. Categorical data usually is not going to have units, but you might be talking about people or responses or something like that. And then you always want to mention again those most frequent, least frequent, anything you tend to find interesting. So if I'm looking at this particular bar chart up here, one thing I notice, I'm looking for my variable. My variable is going to be labeled down here. So freshman, sophomore, junior, senior, those are the categories, but that's not the variable. The variable is class rank in this case. So I would say something like, in the bar chart for class rank, or in the distribution, or in the class rank, maybe not distribution there. For class rank, the most frequent class rank was freshman at about 150, while the least frequent category was senior at about 65. So I'm using real numbers, I'm mentioning the categories. And then in this one, I might mention that it's interesting that sophomores and juniors were the same at about 100. The other thing with the pie chart, if I said, when we look at Marissa's exercise time, her most frequent activity is walking at 45% of the time, while her least frequent activities are swimming and bowling, both at 10%. Now, I don't really see anything surprising about this. The rest of this, anything recognizes, but maybe you know that Marissa's on the basketball team in the context of the problem. So you might say something like, wow, it's surprising that Marissa plays basketball less time than she walks for exercise. That might surprise you in the context of the problem. All right, so we took a survey in class, and for the survey, we ended up with what month were students in this class born, and then we broke it down into season, so like birth season, and we had 4 people who said spring, and 8 people who said summer, 10 who said fall, and 6 who said winter. So if I wanted to make a really quick bar chart for this, okay, the first thing I would need to do would be to give myself some scale over here, okay, and I'm never going to break the vertical axis of a bar chart. We're always going to scale it, and it's always going to start with 0. All right, so I'm going to be like, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's see, here's 8. Here's 6. There's 4. There's 2. Okay, and then I'm going to label this with an F for frequency. That's my how many. Okay, the next thing I'm going to do is I'm going to put these bars. And the reason these are in this order is because that's kind of the month order here. But the only reason, I mean, categorical data, the only reason it's in the order it is because I decided. So I'm going to go ahead and I'm going to draw a bar that is 4 high here for spring. And then I'm going to have a bar that is 8 high. Okay, and that's summer. And when you draw these, one of the things you want to keep in mind is that they should be equal width so that the actual geometric area is proportional to the proportions in the actual problem. Okay, and then we've got 10. I'm going to try to space it out equally here. 10. And I kind of ran out of room, so I'm just going to go up and call that fall. And then finally, we've got 6. All right, 6, and that is winter. And you always want to make sure that you label the variable down here. So I'm going to say the variable is birth season. All right, so I've got my little bar graph. Now, if I wanted to make a pie chart out of this, just a real quick pie chart, I would need to know the percent out of the total. So I take my handy dandy calculator, I go 4 plus 8 plus 10 plus 6, or run that through in your head. We end up with 28 total here. It's our grand total. So to do the relative frequency, I'm basically going to go 4 out of that 28. And 4 out of 28 gives me 0.142 or 143 if I round. Now, a lot of people would say, like, how many decimal places do you need? Because like in AP Calculus, it has to be 3 decimal places, right? Like, okay, in AP Stat, in general, you probably want to use about 3 decimal places if you're talking about a probability or a proportion. But most of the time, they would say you need to round to a reasonable number of decimal places for the context of the problem. You would not want to round this to 0. That would not be reasonable. Okay, so about 0.143 here. I'm going to do the same with the rest of these. So 8 out of 28, that is about 0.286. Boy, that decimal place was large there. 10 out of 28 is about 0.357. And 6 out of 28 is about 0.214. Okay, so those are my proportions. Now, if I want to take and draw this in real life, we would just put this data into Excel and say, make me a pie chart or something like that. But if we do want to sketch this out, you got to think in terms of degrees. We're going to have to kind of guesstimate this. So I'm going to take these numbers times 360 degrees. So 0.143 times 360, I'm looking at about 50 degrees. So I know 45 is going to be at that 45 degree angle. So I'm just going to shade a little bit past what I think that 45 degree angle is. I'm going to label this as spring, and I'm going to note that it is 14.3%. Okay, 0.286 times 360 degrees. I'm looking for something that's 102, so I'm going to think right angle plus a little bit more. Okay, I'm going to label this guy. This is going to be summer. And that is 28.6% there. 0.357 times 360 degrees. That is about 128. Okay, so I think 135 is a straight, is a 90 degree angle plus 45 more degrees. So I'm going to kind of try to shade somewhere in between there. Okay, here is fall. That is 35.7%, and that leaves me here with winter at 21.4%. Okay, now if I want to have a nice perfect graph, I'd pull out a protractor and do it that way. Okay, or pull out some sort of pie chart maker program. That's our basic idea of how to make a real nice, simple categorical graph. Now, another kind of categorical graph we might make is a comparative bar chart. Comparative bar chart is one where we would want to have little clusters of bars. So I have two categories here. I gave a survey and I gave 4 different Star Wars t-shirts you could pick between. And then what is your favorite movie genre? Action or adventure or a romantic comedy out of those two? I want to compare those groups. Now, when you're comparing unlike groups, you can use frequency, but a lot of times it's not very useful. Another kind of, you might really prefer to use that relative frequency. But if I wanted to do the comparative bar chart, I'm going to decide, do I want 4 groups of 2 or 2 groups of 4 in this case? I am going to go ahead and just label these. I'm going to go ahead and use frequency on this. So, boop. Okay, even though we might not be able to make very meaningful comparisons in this case. So I'm going to go, let's see, the biggest number is 60. So how about like, let's see, 10, 20, 30, 40, 50, 60, 20. Let's see, we could do 40, 20, 40, 60, maybe. Okay, we'll put frequency here. And let's do 4 bars, and we'll do a bar for the Leia, a bar for dark side, a bar for the Vader, and a bar for the child. Okay. All right. So we'll kind of do those separately, and I'm going to make a little key up here, and I'm going to say, oh my goodness, my numbers jumped all over the place. Let me see if I can fix this. I'm not sure what's going on my computer. It's like it scrolled maybe. Let's start over here. I did not like that at all. Okay, so let's see, here's my vertical axis. Okay, let's see, 20, 40, I'm going to put 60 right there. Nah, that's not really quite right, is it? Dude, try again. You simply label your vertical axis. Here we go. All right, so how about 20, 40, and 60 here. All right, so I'm going to make myself a little key over on the corner, and we're going to say that the white bar is action and the black bar is romantic comedy here. So I'm going to start off with the Leia shirt, and it says that you had 3 action and 2 romantic comedy. So that's going to be very little small bars right here, not very many. Okay. Okay, there's my, oh, I spelled it wrong, started to write my own last name. There we go. There is the Leia shirt. I'm going to go ahead and skip a couple bars here. We've got the dark side shirt. We've got 60. Okay, and 24. This is by far probably the worst graph I've ever made. Doing this vertically is very difficult. All right. This is the dark side shirt. Okay, I'm going to do 28. And I'm going to skip a space here. I'm going to go 28. And then 5. Let's see, half of that's 10. So half of that would be 5. Would be about right here. Okay. And that is the Vader shirt that was red. And then one more set. We've got the child, which is 6. Okay. And then we've got the bar that is 11. Okay, so that is the romantic comedy section. So that is the child tank there. Okay, so I want to make sure I put my variable here. This was shirt preference. And up here, this was genre preference. So this is going to be kind of this comparative bar chart. Now, unfortunately, the thing is that using frequency is probably a very bad idea here. And the reason why is because frequency a lot of times doesn't tell us exactly what we want to know. For example, let's say that period period 2 has 30 students in period 2. And then you've got, say, period 4. And period 4, they've only got 25 students in their class. And let's say that I'm giving a contest and I say, okay, I'm going to give a contest for who turns in the most homework. And period 2 turns in 28 homework assignments, and period 4 turns in 25 homework assignments. So if all I do is count the number of homework assignments, then period 2 would win because 28 is more than 25. But that doesn't really compare the performance of the class. In fact, period 4 outperformed period 2 because 100% of students turned in their homework, whereas period 2, less than 100% turned in their homework. So is it really fair to count the raw number? Does that really compare the two classes appropriately? A lot of times if you have two different size groups, it's much more appropriate to compare their relative frequencies than their actual frequencies. In fact, basically, anytime you're looking at that vertical axis, you want to use relative frequencies, especially if your sample sizes or your group sizes are not the same. It'll give you a much more meaningful thing to say. Right? Now, a contingency table, or sometimes called a two-way table, is when you organize the data in, like we had with the romantic comedies and the shirt choices, and you give all that data here. One thing, you were looking at these raw numbers. So again, with this idea of sample size, the question was, what's the ideal distance between college and home? So if you look at just the raw numbers, the people that said less than 250 miles, that means pretty close to home. There's over 4,000 students. And for parents, there's like 1,594. So the issue with this is this looks like a lot more students said close to home than parents. And if you're counting, in reality, there were a lot more students that answered that. But that really isn't the story that's going on here. If you look at the rest of the numbers, there were a lot more students who said less than 250 miles than parents, but there were also a lot more students in general than there were of parents. Right now, it looks like students are almost 3 times as likely to stay close to home than parents are. But if you look at the relative frequency instead, that 1594 is like over half of the parents, and it's only about a third of the students. Okay, so using that relative frequency is a better decision. Okay, using that idea of the part out of the whole as a percentage, you're going to much better graph. So if we wanted to improve this graph up here, what we should do is think about not as Leia being 5. Okay, 5 total little itty bitty bars here. But we should probably make our bars percentages and say that the action movies were 3 out of 5, or 60% of the people who said Leia answered action movies, and 40% of the people who answered Leia, or answered rom-com, of those Leia people. Okay, so that's a more appropriate way to compare those values. Okay, one thing you do need to be able to do when working with a contingency table, or one of these, is to be able to find something called the marginal distribution. Marginal distribution is just another way to say what's the relative frequency of a certain category or of a set of categories. Remember, distribution is the stats word. This sort of means how everything is spread out, where everything is. I like to think of it in terms of categorical data. It's how the 100% is split up and where those values landed. So if I look over here, it says find the marginal distribution of gender. What that means is what percent of the total were female and what percent of the total were male. So even though we have this other variable, which is accounting, economics, statistics, they're major, this is what we really want to look for. Okay, so I'm going to look at this first set, 44 and 30 and 24. That gives me 98. And 56 and 30 and 16, that gives me 102, giving me for a total of 200. All right, so for females, 98 out of the 200 females, that gives me that the relative frequency for females is 49%. That's what I would get if I took that 90 out of 200. So in terms of males, that must be that they are 50% or 51%. Okay, so that's my distribution. How is 100% split among these categories? Now over here, the marginal distribution of major means I want to know this time what percent are accounting, what percent are economics, and what percent are statistics. Okay, so goodness, I made that way too big. I was trying to make it a little bit bigger, not just a ton. Okay, so again, when I look here. Okay. I see 44 and 56. I'm going to erase some of those marks, but you get the idea that those are the columns there. There are 100 of those, and there are 60 economics majors, and there are 40 statistics majors out of the 200. So when I go to talk about the marginal distribution, the percent that are accounting would be the 100 out of the 200, or 50%. Economics would be 60 out of the 200, or 30%. And the statistics would be 40 out of 200, which is 20%. There's how my 100% is split among the categories of this variable for major. Okay, I need to be able to answer questions like, what percent of the class is male? And again, what percent from 0.51? So that would be 51%. What percent of the class majors in economics? That would be 30%. Here I have a question that says, what percent of the class, so out of that 200 is male and statistics. So I'm going to go up here. Out of the 200, how many were male and studying statistics? That's 16. 16 out of 200. Okay, so we're talking about 8%. Okay, what percent of the class, so again, of the class, are female accounting majors? So out of that 200, there are 44 female accounting majors. Okay, so we're looking at about 22% of the class. Okay, so using the marginal distribution we can read these contingency tables and get some of these values. The other side of this is something called a conditional distribution. Now, the conditional distribution, if you've studied conditional probability before, we're applying some sort of condition on our problem. Ultimately, the difference between this and marginal is that you're talking about the relative frequency with respect to some subpopulation. Or in other words, you want to think about a single row or a single column representing 100% instead of just the total. So we'd be looking at questions like, what percent of the females are accounting majors? So not out of the total anymore. I'm not interested in out of the class. It's literally just out of the females. So out of those 98 females, what percent are accounting majors? Well, I would do 44 out of 98. Okay, I put that in my handy dandy calculator. 44 out of 98 gives me 0.449. Okay, so about 44.9%. Okay. If I said what percent of the statistics majors are male, and again, I'm not looking at of the total anymore. I'm looking at of the statistics majors. So I'm only looking at these 40 individuals that are studying statistics, which means my grand total is out of 40. And I have 16 of those are male, okay, and that's going to give me 0.4 or 40%. So this is that conditional kind of probability, that conditional, right, we're applying some condition and saying just out of this part, not out of the whole thing, but just out of this little part. And the reason why we want to do that is because those kind of probabilities, considering a subgroup as 100%, can really let us compare a couple of variables using something called a segmented bar chart. Now, beginning of class, we talked about a bar chart. We like a bar chart, and we like a pie chart. This kind of puts the two together. It's kind of a marriage of the two. It is basically a square rectangular pie chart. It's like a cobbler chart or a pan of brownies chart. Okay, what we're going to do is instead of making 100% a circle, we make a rectangle that is 100%. And instead of cutting wedges out of it, we slice it in slices of the appropriate percentage. So in making a segmented bar chart, what you're going to see is that you're going to have a bar that represents 100% of a group. So here I have males and females, and they both are 100%. Each section is going to show the percent of that subgroup that it is our second variable categories. It's really important when you do this that you use relative frequency instead of frequency, because almost always you're going to have different size groups when you deal with this. So we do not want this graph that has frequency on the vertical axis. We want this one that has relative frequency on here. And the reason is because if you look at this red section, for example, in the one that uses frequency, it appears that the same number or an equal amount of men and women answered this question saying no stress. And that's true. The same number did answer, but what we're actually ending up is that it's almost 40% of the men, but it's only about 20% of the women. In reality, it's like twice as much in terms of percentage. So we have a more meaningful comparison between those two groups of sample sizes if we use the segmented bar chart instead. All right, so I need to go back and grab these numbers because I did not type them in. And let's see if I can grab those really quick. So those were 3, 2, 60, 24, 28, 5, 6, and 11. And by the time I scrolled back, I know this is 6, 11, and that is 3 and 2. All right, I'm getting there. All right, I forgot what it was now. 60, 24, 25, 28, 5, 60, 24, 28, and 5. All right, so here is my raw counts. These are my frequencies. What I want to do is I want to do a conditional distribution. So I have to decide whether I want to do 2 bars that have 4 sections or I want to do 4 bars that have 2 sections. I'm going to go ahead and do 2 bars that have 4 sections. So I'm going to go ahead and look like action is 100% and romantic comedy is 100%. So I'm going to take my calculator and I'm going to do 3 plus 60 plus 28 plus 6. And this has a total of 97. And then 2 plus 24 plus 5 plus 11. This has a total of 42. All right, so those are my grand totals right now. Okay, and then I'm going to find the conditional distribution. All right, conditional distribution here. So the Leah blue shirt, I'm going to do 3 out of 97. 3 out of 97. And I'm just going to use 2 decimal places for this right now. That is 3%. And the dark side shirt, okay, so this is for action, that would be 60 out of 97, which is about 62%. Okay, we've got our Vader red shirt, that's going to be 28 out of 97, which is about 29%. And the child tank, which was another shirt option, 6 out of 97 is about 6% rounded to 2 decimal places. Okay, and if we've done this properly, these should add up to 100%. Okay, and I can kind of eyeball that, and I'm pretty sure that's right. I'm going to go ahead and do the romantic comedy then. I'm going to take 2 out of 42 this time. 2 out of 42 is about 5%. 24 out of 42 is about 57%. 5 out of 42 is about 12%. Okay. And 11 out of 42 is about 26%. And again, if I've done this properly, this should add up to 100%. I have 2 bars, each worth 100%. I'm going to go to my graph paper up here and make this just a little bit smaller. Okay, go to my graph paper and I'm going to draw a vertical axis. Okay. A horizontal axis for my bars to sit on, and I'm going to go up to 100%. So I'm just going to go like 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And this is relative frequency. And the next thing I'm going to do is I'm going to draw 2 bars, so 2 square pies. And these bars are 100% tall. Okay. All right, so 2 bars that are 100% tall. Okay, this first bar is going to be action. And the second bar is going to be romantic comedy. And then remember that the variable needs to go on there as well. That would be preferred genre. Okay. The other thing I need to do is I need to make a key for the other variable. Okay, and normally I would do this kind of over to the side here. So I'm going to say shirt preference. Okay, there's my variable shirt preference. And I'm going to use just a solid colored in black for the Leia shirt. And I'm going to use kind of like a stripe for the dark side shirt. I'm going to use just plain white for the Vader shirt. And we'll do maybe some like polka dots or something for the child shirt. Excuse me. All right, so now I'm going to go to graph these. So the first one I need to get is this 3% of the people who had action movies, the 3 out of the 97, the 3%, preferred the Leia shirt. So I'm going to go over and I'm going to mark 3%. All right, 3%. So here's 10%. So 3% is going to be way down here. It's not going to be very much at all. Okay, there is that 3%. Okay, and now I'm going to put these next two together. So I'm going to think I was at 3% and now I need to go 62% up. So if I was at 3 and I go up another 62, my next line needs to go at 65. So my next line is going to go kind of right here, and then I can draw those diagonal bars. Okay, to shade it in. And then I'm going to think, what do these three do together? So if I had 3% plus 62% plus 29%, that puts me at 94. So my next line needs to be at 94%. I'm going to be somewhere there. And that should leave me with about 6% left on the top. And that needs to be kind of that little polka dotted shade there. Okay, I'm going to do the same over here. I'm going to start with 5%. So I'm going to mark that off 5%. That was probably a little high there. I'm going to put these together and I'm going to say, what would 5% and 57% together be? That would be 62. So my next line needs to be up at like 62. We're very similar in these two graphs. Okay, I'm going to go up another 12%. If I'm at 62% and I go up another 12, that puts me at 74, which is somewhere in there, leaving me with about 26% up at the top. Okay, my little dotted there. So these are my segmented bar charts. So I can see that while the people who answered action and romantic comedy were very similar in the percentage that chose the Leia shirt and the dark side shirt, they were very different in the percentage that chose the Vader shirt and the child shirt. The percentage of action movie people who chose the child shirt was significantly smaller than the percentage of romantic comedy people who chose the child shirt. Okay, and then vice versa for that Vader shirt. So that's my segmented bar chart. Okay, all right. Let's go down here and make one more segmented bar chart for practice. So this is talking about students and staff. It says students and staff we went to the parking lot and we noted what origin their car, like what the manufacturing country of origin was. And we classified that by continent region. And then it says what kind of driver it was. So they looked at the parking tag. And so this example says, use the conditional relative frequency distribution of the origins based on driver to make a segmented bar graph. All right, so let's break this thing down because there's a lot of words right there. Use the conditional relative frequency distribution. So we want to know the distribution of the origins. How are the origins? How are American, European, and Asian manufactured vehicles? Okay, how is 100%? This percent American, this percent European, this percent Asian. How are those split up based on driver? That means that we're going to make the bars or our subgroups in our segmented bar chart that driver, and we're going to have the percentages inside those categories be the origin. Okay, so I'm going to start off here and I'm going to look at students. This is going to be like bar 1, and staff, this is going to be bar 2. I'm going to find these totals. 107, 33, and 55 gives me a total of 195. And then 105 and 12 and 47, that gives me a total of 164. Okay, those are my totals. Now I'm going to go down here and I'm going to find this conditional distribution here. Okay, so I'm going to have American, European, And Asian manufactured vehicles, I'm going to have students and I'm going to have staff. I'm going to have separate sets of percentages. And if I've done this properly, they should both add up to 1. All right, so I'm going to take, for the first one, I'm going to take 107 out of 195 to get this first percentage right here. So 107 out of 195, and that is, for the sake of just our example here, I'm going to use 2 decimal places, 55%. 33 out of 195 is about 17%. And 55 out of 195 is about 28%. We put those together, we get about 100%. I'm going to do the same thing with staff. 105 out of 164, that is about 64%. 12 out of 164, that is about 7%. And 47 out of 164, that is about 29%. All right, so those are my conditional distributions of the origins based on gender, or sorry, based on driver. Okay, so I'm going to go over to make my segmented bar chart. I'm going to have 2 bars. Okay, and I'm going to go ahead and go like 10 and 20, 30, 40, 50, 60, 70, 80, 90, 100, and I'm going to label it, this is relative frequency. I'm going to have 2 bars that are 100% tall. Okay, these are our cobbler charts instead of pie charts. Wow, those are wobbly looking, aren't they? Hopefully your paper is a lot neater than mine. All right, and then I'm going to have students and staff. And then I'm going to label that this is the type of driver. Okay, got my variable labeled down there. I'm going to go ahead and make my key. I need 3 categories. So for origin, for the American-made cars, I'm going to go ahead and just put kind of little stripes there. That's going to be the American-made cars. And I'm going to leave the, let's see, we'll make European-made cars. We'll color those in. That'll be just solid. Okay, and then finally for the Asian made cars, we'll just go ahead and leave that one blank. That'll be what's ever left over. Okay, so there's our origins. All right, so I'm going to go over the 55%. I'm going to go 55, 17, and 28. So 55%, here's 50. I'm going to go up and mark off about 55%, and I'm going to mark that for American. I'm going to put these together, 55 and 17. I'm going to think if I was at 55% and I went up another 17%, that's going to put me at 72%. So my next line is going to be at about 72%. I'm going to go ahead and fill in that next color there. Okay, and that should leave me with the top about 28, and I think that's what that looks like. Okay, the next thing I'm going to do is 64, so I'm going to 64%. I'm going to mark off about where I think that is. Okay, and then I'm going to go up another 7%. If I'm at 64 and I go up another 7, that puts me at 71, so almost exactly where I already was. And then I've got about 29% left over on the top there. Okay, so I was going to talk about how do these compare. It looks like the percentage of students and staff that own Asian manufactured vehicles, got your Toyotas there, those are about the same. However, it looks like the percentage of students who own European cars is larger than the percentage of staff who own European cars. And on the opposite side of that, it looks like the percentage of students who own American-made vehicles is much smaller than the percentage of staff that own European-made vehicles. Okay? Another thing that we can use this kind of graph to talk about is independence, but that'll be in another video. All right, so good luck with your segmented bar charts and other categorical graphs.